So by the time we have discussed about U substitution method and how it works in evaluating indefinite integral and indefinite integral. Okay, so after these two concepts, we are ready to go forward because we are going to start some complicated parts here. So first of all, we are going to focus from integration by parts. Besides this, we will learn another technique that is called tabular method, and it will be one speedy process. Okay, so let's learn what is integration by parts. Okay, so we are starting integration by parts method, and you will find this concept in section 7.2 from Howard Anton's book. Okay, so besides this, we will focus on another technique that is called tabular method. Okay, remember, besides integration by parts, we will focus on tabular method also. So first of all, let me start from the theoretical part. If we have u times v dx. Okay, first of all, again recall the fundamental theorem of calculus. That is, we are integrating f of x from x equal to a to x equal to b. Then finally we will get one area. Okay, but we will get at first the answer of integration, which is now known as antiderivative, upper limit, lower limit. So in order to solve this one, we can apply the fundamental theorem of calculus, and it says antiderivative at upper limit b, negative antiderivative at lower limit a. Finally, we will get area. Again, we have learned another concept that is a tricky process. If we have complicated integrals, complicated definite integrals, we may have to use U substitution method. But what we can do at first, we can at first find the respective indefinite integral. Then finally, if we have the antiderivative, we can apply upper limit and lower limit. Okay, so this is how we can proceed. So this, in this part, that is in integration by part, the function that we have here, f of x, it may be of this form, u times v. That means the function what we have here, that is like this form, u times v. It may be f of x equal to, suppose we have sine x e to the power x. We may have f of x equal to x squared e to the power x. So you can see that we have one part, another part. That means these two parts are in product form. E to the power x, sine x, that is again in product form. So now we have to know how we can deal with this type of integrals where we have u times v form. So first of all, there is a common method that is called L I A T E. So you can see I have written one part that is called L I A T E. So what does it mean and why we have to use this concept? So at first, let's figure out what L's for. So L stands for logarithmic function. Suppose log x, natural log x. We may have L. ln x squared, just like that. So L means logarithmic function. I means inverse trigonometric function. That means I mean to say tan inverse x, we may have sine inverse x, we may have cosine inverse x over x squared plus 1. So this type of functions are under inverse part. Okay, so I stands for inverse trigonometric function. A is for algebraic function. Algebraic function means polynomial function. What do you mean by polynomial? Suppose we have x squared, we may have 2x. If we have x cubed plus 1, we may have x squared plus 5x plus 6. So these functions are called algebraic or polynomial function. Okay, so this is called A. What is T? T stands for trigonometric function. That is sine x, cosine x, tangent of x, cotangent of x, like this. What is for E? E stands for exponential functions like e to the power x, e to the power negative x. We may have e to the power negative 2x. So this kind of functions are called exponential function. So why we have to use this method, LIATE? So this concept will allow us or will suggest us, out of this u and v, which part should be taken as u. Suppose we have a function e to the power x sine x. So someone may consider this one as u, this one as v, or other students may take it is v and this is u. So confusions will arise. Okay, so just to remove this confusion, we can take the help of LIATE. So this part is for taking u. So u can be considered, remember it is just for this concept is just used for considering u. Okay, so u can be considered based on this serial. Suppose we have logarithmic function and exponential function. That means e to the power x log x, or e to the power x natural log of x. So if we have this type of integral, so we have to know, out of these two parts it is in uv form. At first we can guess, but which part should be considered as u, you have to understand by using LIATE form. So you can see that here we have combination of logarithmic function and combination of exponential function. So L and E, according to LIATE, L comes first then E. So that means u will be ln x. So that means in next part we can rearrange this thing like this, that is integration of natural log of x e to the power x dx. So we can make this change. Okay, that means now we can easily understand that it is u and this part is v. So before going to apply u substitution in integration by parts, we have to understand LIATE clearly. I am showing you another example. Suppose we have integration of e to the power x sine x dx. At first sight we can say this is u, this is v, because we have product from u v, but it is not like that. We have to check that if we remember LIATE, so you can see that this is exponential function and this is trigonometric function. So according to LIATE method, t, that is trigonometric, comes first then exponential. So what we have to do here, we can just rearrange this one, that is sine x e to the power x dx. Now we are sure that this part will be u and this part will be v. Okay, so before going to apply integration by parts method, we must have to figure out which function should be chosen as u. That is our first and foremost duty. Okay, so let's try to understand what is integration by parts. So integration by parts, that is integration of u v dx. We have one specific formula. Okay, suppose we have figured out which function will be u and which function will be v according to LIATE form. Now just to solve this integral, what we can do, the formula says that we have to go by this way, that is u integration of v, negative differentiation of u integration of v, and integration over this part. So this is called the formula for integration by parts. Okay, if we have integration of u v dx, then u integration of v minus differentiation of u integration of v, and total part will be under integral. Okay, so this is how we can easily solve if we have one integral with product form. So let's take one example. Suppose we have integration x e to the power x dx. Okay, so you can see that this is under u times v form, but we have to figure out which function, either x or e to the power x, which function will be u. We have to figure out by using LIATE concept. So you can see that x is algebraic function and e to the power x is exponential function. So we have the combination of a and e. So that means obviously x will be u and e to the power x will be v. So x e to the power x dx. Now try to recall the formula. So the formula for integration by parts is integration of u v dx, that is equal to u integration of v negative differentiation of u integration of v and integration over this part. Okay, so we will go by this way, and we can easily solve this complicated integral by using this concept. So we have u equal to x and v equal to e to the power x. Let's write down this one, u equal to x and v equal to e to the power x. This will help us to figure out. So now I am writing integration of u v dx, that is u x integration of v, that is e to the power x, negative, we can see a big integral is here. Okay, differentiation of u part, and u is x. So let's input x here. Then you can see there is another integral. Then v is e to the power x. So let's try to solve this one. Now we can directly apply the formulas of integration. You know that integration of e to the power x dx is actually e to the power x. We are applying the basic formulas, and I have already mentioned you that you will find your basic formulas in this reference books. Okay, so integration of e to the power u du, that is e to the power u. So we are using this thing, negative integration. Now try to solve this part. So differentiation of x with respect to x, that is giving us only 1, and integration of e to the power x dx, again we will get the same result. So here we are getting e to the power, let me write again, e to the power x, and we have finally dx. So what we can write now, x e to the power x negative 1 times this one is the same one. Now it is easy to solve again. That is x e to the power x negative. Again we have the formula integration of e to the power x dx, that is e to the power x. So this is how we can apply integration by parts for these complicated integrals. Okay, I hope you have understood what I am trying to say. So things will be more easier if we try to practice from our reference books. Okay, so for you I am taking another example. Suppose, so whatever problem here we have done, that is indefinite integral. We don't have any lower and upper limit. But now I am thinking about one problem that is with definite integral. So suppose we need to evaluate integration from 1 to 2 natural log of x in terms of x. Okay, so this time we have a definite integral. Definite integral means we have both lower limit x equal to 1 and upper limit x equal to 2. But what I have suggested you previously, that is, if we have complicated integrals, or suppose at first we have definite integrals, what we can do, we can at first find the respective indefinite integral. That means we can forget about this one for now. Suppose we don't have the limits, so let's try to find out the antiderivative for this integral. Okay, where the function is natural log of x, that is ln x. So there is no direct formula for this integral. We know that integration of 1 over x dx, that is equal to natural log of modulus x. But is there any formula for ln x dx? Actually we have, but how we can find the result, we are going to discuss here. You can search on your reference book. You will see integration of let me find at first. Yeah, this one. You can see we have integration of this one, and the result is u ln u negative u. Or suppose if we have integration of ln x, then it will be x ln x negative x. So the result is here. We can use this formula for our advanced problems. But now, since we have been asked to evaluate this one, so we have to show all the steps. Is that okay? So how we can do this one? This type of problems can be solved by integration by parts method. And in integration by parts, you know that we must have u times v as the function. But what we can see here, we have just one part, natural log of x. So where is the other one? That is, it may be ln x e to the power x. That means you have u and v. But for this case, whatever problem we have here, or whatever function we have here, it is just for natural log of x. So how we can apply integration by parts method? That is a question. Okay, so I'm trying to show all the steps here, but for now, try to understand that natural log of x with 1, that means if we multiply 1 with this one, things is just same as before. That means if we multiply 2 times 1, we will get 2. 3 times 1, we will get 3. So ln x times 1, we will get ln x. So using that concept, we can extend our idea. Okay, so now we can see that we have total two parts. Maybe first part is u, second part is v, but how we can be sure? We can check, we can have a look on LIATE form. So LIATE. Here we can see we have logarithmic function and one is algebraic function. So we have the combination of logarithmic and exponential. So since logarithmic comes first, then algebraic, so we must have to take natural log of x as u and the other part must be v. So we are writing this one here, u equal to natural log of x and v equal to 1. This is our information. So let's again write down the formula so that we can easily find the antiderivative. So integration of uv dx is integration of v dx, negative differentiation of u, integration of v, and integral is over this part. Okay, so using this concept, let's try to find the antiderivative for this integral. So here you can see that at first u is coming, so u means natural log of x, integration of v, v is 1 dx, negative total integration here we have. So inside this part we have ddx of u, so ddx of natural log of x times integration of v dx, so v is 1 again dx. Now we know that integration of 1 in terms of x is actually x. Okay, that means integration of 1 in terms of u will be u, integration of 1 in terms of x will be x, integration of 1 in terms of w will be w. So variable doesn't matter, but remember, if we have constant 1, it will be just that variable. So for this we have written this one, negative differentiation of natural log of x. You know this formula, that is ddx of natural log of x is equal to actually 1 over x. So for this we can write 1 over x, and again for this part, different integration of 1 in terms of x is actually x, and with this we have dx. So now it will be x, we are just rearranging these terms, x natural log of x negative, so here we can cancel x and x, so which gives us just only 1, so 1 dx. So again we are getting x natural log of x negative integration of this part in terms of x is x. So finally we are able to find the antiderivative, okay, or answer of integration. That means if we have integral ln x dx, then the antiderivative will be this one, that is given in this formula. Okay, so we can prove any formulas using our theoretical concept. So that means integration of natural log of x dx is this one, x natural log of x negative x. So now don't forget that we have to find the area. That means previously we have the definite integral from the lower limit 1 to upper limit 2. So let's think about these limits now. So lower limit is 1, upper limit 2. So since we have the antiderivative, so we can apply the fundamental theorem of calculus. So fundamental theorem of calculus says that and input upper limit and lower limit where you have the input variable. Input variable is x. Here we have x. Here we have x. So in these places we have to apply the fundamental theorem of calculus, or we have to input upper limit and lower limit. So remember 1, 2, 3, these three parts are our input. So here recall the fundamental theorem. If we have AB f of x dx, then capital Fx is the antiderivative, where we have a input upper limit, negative where we have x input upper limit, where we have x input lower limit. So that is the thing what is known as fundamental theorem of calculus. So here we have x. First of all, we are going to input upper limit. So 2, upper limit is 2, so we are inputting 2 here. Natural log of 2, negative 2. So first part is completed. There is a negative sign. It is coming from direct fundamental theorem of calculus. Then again we have to input the lower limit where we have x. So this is x 1, natural log of 1, negative 1. So let's try to evaluate the value. That is, we are getting 2, natural log of 2, negative 1, negative, we are getting natural log of 1. Okay, directly we can write, we know that natural log of 1 is actually 0. So we have negative 1 here. So finally, we can write 2, natural log of 2, negative 2, negative negative is becoming positive 1. So 2, natural log of 2, negative 1. So this is our final result. For the definite integral, integration from 1 to 2, natural log of x dx. But just to solve this integral, we have applied integration by parts technique. Okay, so I have mentioned that every definite integral will give us a finite value. So you can keep your answer in this form, 2 natural log of 2 negative 1, or you can use your calculator just to find the numerical value. Okay, if I use my calculator, the result will be 0.386. So this is a finite value which is defining the area of under this function from x equal to 1 to 2. Okay, so I hope up to this part you have understood what is the application of UV technique, that is integration by parts technique. Okay, so let's take another example. Suppose we have integration x squared e to the power x dx. I am taking one indefinite integral now, because already I hope you have understood what is integration by parts. But don't forget that besides integration by parts, we have to learn what is tabular method. So but before that, let's try to solve this integral using integration by parts technique. So again, you can see that we have algebraic function x squared and exponential function e to the power x. So let's recall LIATE. Here we have algebraic and exponential combination. So that means algebraic comes first, then exponential. So u will be algebraic part x. So we can easily figure out u will be x squared and v will be e to the power x. So again, using uv dx, that is integration by parts method, we can write u integration of v, negative differentiation of u, integration of v, and integration under this part. Okay, so here let's try to solve by this way. U is x squared, so x squared e to the power x dx, negative differentiation of u is x squared, integration of e to the power x dx, and total integration. Okay, so you know that this will be x squared, and integration of e to the power x dx, that is going with a direct formula, it is e to the power x. And now we can write integration, differentiation of x squared in terms of x is actually 2x, integration of e to the power x is becoming e to the power x. So this time what we have to do, you can see we have x squared e to the power x, negative 2 is constant, so 2 can be pulled out before this integral sign, so we have x e to the power x dx. So you can see that we have again uv part. So again the same process, same technique will be repeated. Okay, so that means we are trying to find the antiderivative for this integral where we have x squared e to the power x, but finally we have applied this one and we are getting another integral part. So just to solve this one, let's apply the same technique again. So x squared e to the power x, negative 2. So again we have here, we can recall LIATE method. So that means x is exponential, x is algebraic function, and e power x is exponential function. So for this u will be x and v will be e to the power x. So let's try to apply integration by parts again. So integration by parts means u integration of v, negative differentiation of u, integration of v, and we are using a square bracket just to separate that we are integrating this part only, and before we have the constant 2. Now let's try to simplify this one. So here we have x squared e to the power x, negative 2. Here we are getting x. Again you can see that integration of e power x dx, that is e power x. Now we have negative, so negative, there is an integral sign here, integration of, sorry, differentiation of x in terms of x, that is actually 1, and integration of e power x is giving us e power x. We have dx here and there is a square bracket. So here finally we have x squared e to the power x, negative 2, negative positive negative, so 2x e to the power x, negative negative positive, so we are getting 2 integral of e to the power x dx. Now we are getting our final answer, but just we have to solve this integral. So that is x squared e to the power x negative 2x e to the power x plus 2. Integration of e to the power x is e to the power x. Okay, so we are getting the final result. So this is how we can apply integration by parts. Okay, so our target should be at first finding u by using LIATE method, and then we can apply this formula. So now let's move to tabular method. Whenever you will start the second part of this course, that is differential equation, then for some differential equation maybe you have to apply in the concept of integral calculus, and you will get some functions like uv, which is in the form uv. So instead of using integration by parts technique, you can also do tabular method. Okay, so it's wise to learn from the very beginning. So we are going to discuss tabular method for now. You will find the concept in section 7.2, that is integration. Besides integration by parts, you can see integration by parts, you have the tabular method here. Okay, so you can see that we have a function px times f of x. So I'm not going with this one. Let's come to here. So again, here we have u times v dx. This time, remember, if u is an algebraic function, algebraic means polynomial function. Polynomial functions are x, it may be 1, it may be 3, it may be x squared, it may be x cubed plus 1, it may be x squared negative 5x plus 6. So these functions are called polynomial function. Okay, so if we have the combination of polynomial function and some other parts, so what we can do, instead of applying integration by parts technique, we can also solve the same integral by using tabular method. Okay, so let's at first discuss what is tabular method. This is an alternative technique for u substitution method. So from this name you can see that you can easily understand that there will be a table. So let's draw one table. That table will contain 3 columns. The first column will be for sign chains. I have written SIGN, not SIN. Okay, so sign means symbol. Positive, negative, all these things are I'm trying to mention. Okay, so this is sign. This column is for sign. This column, the second column, is for repeated. I'm mentioning repeated differentiation. Repeated differentiation column. And the second part is the last column, that is third column, is for repeated integration column. Okay, so you can see that we have here u and v. So remember, u will be placed in the second column, that is under repeated differentiation column, and v will be plugged here, that is in third column. So suppose we have integration x square e to the power x, so that means here it is polynomial function and it is exponential function. Since we have polynomial function, we can solve this one by integration by parts technique, or we can also solve by tabular method. But if we apply tabular method for these problems, then things will be, that means we will get the solution easily. Okay, that means that will be one speedy process. So instead of using integration by parts, we can also apply tabular method. But remember, tabular method is only applicable for polynomial functions. Suppose we have exponential and trigonometric function. So for this, we have exponential and trigonometric, combination of exponential and trigonometric. So for this, we can apply integration by parts method, that is this one, but we can't apply tabular method. Tabular method is only applicable for this one. If we have polynomial, then only we can apply tabular technique. So this is the limitation of tabular method. Okay, I hope you understand my point. Okay, so let's get back to here. So in this part, here we have to place u, and here we have v. Okay, and the first part will start with positive sign always. So in next row, that is, since this is under repeated differentiation column, repeated differentiation means we have to differentiate again. Okay, so that means differentiation of u, again differentiation of, let me write by this way, u prime, u double prime, u triple prime, that is first derivative of u, second derivative of u, third derivative of u, and this process will be continued until we get 0. So why we are expecting for 0? Since tabular method deals with polynomial function, suppose this one, if u, that is x square, is under this part, it is must that after some differentiation part we will get obviously 0. That means differentiation of x square is 2x, differentiation of 2x is 2, differentiation of constant 2 is finally 0. So that is the thing what I am trying to say. So this is for repeated differentiation column. Our calculation will stop if we get 0. Then we have to focus on the third part. The third part is repeated integration. So once we have v, we have to integrate v. Then there will be one answer. Suppose it is v1. We have to integrate v1 again. There will be an answer, that is antiderivative v2. We have to integrate v2 dx. It will be v3. So the same process will be continued. And since we have 0 here, that will be the last part. So suppose it is v3, v4, v5, v6. Let's say it is vn, integration vn minus 1 dx. Okay, so after completing differentiation column and integration column, we have to focus on the sign. I have mentioned that always it will start with positive part. So now use alternating sign, that is once plus, then minus, plus, minus, plus, minus. So this is how it will work. Now finally, integration of, we have to find integration of uv dx, not by integration by parts method, but we have to find out the solution for this one or antiderivative by using tabular method, because we have this time algebraic function. So what we have to do, we have to multiply by this way, first part with this one, then this. You can say this is one kind of cross multiplication. So but it will come by this way. So that means what I am trying to say, multiplication of u times v, these two will correspond, u prime and v2 will correspond, u double prime and v3 will correspond, and this process will go on. So that means how we can write, multiplication of the result of this integral will be, the result of this integral will be u v1 at first, then u prime v2, then u double prime v3, and this process will go on. But you can see I have written the product parts inside parenthesis, okay, because there is we have to, that means there is a concept for sign change, so we have to focus on the sign. So how we can focus on the sign? Remember, if we have suppose plus, suppose all these are plus, so we have to come by this way. What will be the sign before this term? What will be the sign before this term? Is it plus or minus? We have to figure out. So how we can figure out? For the first term, we will come by this way. Here you can see plus, 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 plus. Suppose we have plus, so plus, 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 plus. For the second term, u prime v2, we can come by this way. Minus, plus, minus, minus, plus, minus. For the third term, plus, 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 plus. That means at first you have to come from horizontal direction, then by that cross product form. So this is the theoretical concept of tabular method. Instead, if you can solve the integral by using integration by parts, you are most welcome, but I am trying to explain tabular method besides this. I hope this will help you in some parts. Okay, so this will help you in some parts of this course. So let's take the same example. You can see we have solved this problem by using integration by parts technique, and for this we are using LIATE form. But since we have, you can focus on here, we have algebraic x squared. So the same problem can be solved by tabular method. Instead of using integration by parts, we can also have a look on alternative technique, that is tabular method. So whatever process we will apply, that doesn't matter, the result will be same, this one. So let's try to solve this problem by using tabular method, then you will understand what I am trying to say. So the integration that we have here, integration of x squared e to the power x dx. Let me check again, x squared e to the power x dx. So here you can see this is the answer. Let's see, we are going to apply tabular method now, and let's see what will be the result this time. The result must be same. So here we have algebraic function and exponential function, so we can think about tabular technique. So what we can do, we can make these columns. First column is for sine, second column is for differentiation. Instead of differentiation word, I am writing it is d, and the last column is for integration. In short, I am writing I. Okay, in differentiation column we have to place x squared, and we have other part that will be here e to the power x. And the first part will start with sign plus. So now we have to just recall the theoretical part, differentiate this part again. Okay, so same process will be applied here, and for this one we have to integrate again. Okay, so this is called repeated differentiation column, this is called repeated integration column, and the process will be continued if until we get 0. So differentiation of x squared is 2x, then differentiation of 2x is 2, differentiation of 2 is 0. So this is our last term. Let me draw the rows. Okay, so once we have found 0, that suggests us that this is the last term, and now we have to integrate e to the power x repeatedly. So integration of e to the power x dx, that is again e to the power x, integration of e to the power x is e to the power x, integration of e to the power x is again e to the power x. So finally we are done. Okay, now focus on the plus and minus sign. So always it will start with plus, then alternating sequence will be negative, then positive, then negative. We are stopping here because we have 0 here. So what we have to do here, now we can see the first term, the first part will correspond with second part, not with this one. Okay, so let's do the same thing here. This part will correspond with this one, this one will correspond to this one, and 2 will correspond with last one. So that means integration of x squared e to the power x, the result can be written by this way. Integration of x squared e to the power x will be the multiplication of x squared and e to the power x. At first I am writing the product forms. All this will be in product form. Okay, so x squared e to the power x, see, I am writing all these things in parentheses, just like this one. And then multiplication of x squared e to the power x is here, then multiply this one and this one, see the corresponding. Okay, so it will be 2x times e to the power x, and then you have to multiply 2 with e to the power x. So these are the three terms we have finally. Now we have to figure out what will be the sign here, here, and here. Okay, so for this part we will come by this way. Here you can see plus x squared automatically with plus. So for first term x squared to the power x, we will have plus 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 plus, we are getting plus. Okay, I hope you have understood. Similarly, for the second product 2x e to the power x, we have to come by this way, negative positive. You can see here we have positive, so negative positive negative negative positive, we have negative. Finally, let's think about the last part, that is 2 times e to the power x. So positive 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 positive, finally we are getting positive. So this is how we can figure out the sign before all these terms, okay. So finally we have the result in our hand, that is, it is x squared e to the power x negative 2x e to the power x plus 2 e to the power x. So integration of x squared e to the power x dx is this one, and let's verify. You will get the same result here. We have found the same result here, where we have applied integration by parts techniques, but same result has been found by using tabular method. So I hope you have understood what is tabular method and how we can deal with tabular technique and integration by parts. Okay, so I will show another example so that you can easily figure out. So let's say we have x squared sine x dx. We can use integration by parts technique, but we will not do this one because this time we can easily solve this by using tabular method. Since we have x squared as polynomial term, so since we have polynomial function or algebraic function, we can easily apply tabular technique. So this is polynomial or algebraic and this is trigonometric. So let's apply tabular technique because we are not going to apply integration by parts. You can also do that one, but for now I am going by this way. So first column will be for sign change, second column is for differentiation, and third column is for integration. So first part will start with plus. Under differentiation column we have to place the algebraic function or polynomial function x squared, and automatically sine x will be under integration part. So at first what we have to do, we have to differentiate this part. So repeated differentiation will go on, that is integration of differentiation of 2x, sorry, differentiation of x squared is 2x, differentiation of 2x is 2, differentiation of 2 is 0. Finally this is our part, last part. Now differentiation column is okay, we have to focus on integration column. So you know that integration of sine x dx, that is nothing but negative cosine x. So if we integrate this part, we will get negative cosine x. Now we have to integrate again this one. You know that integration of cosine x dx is equal to sine x. So and before we have negative, so integration of cosine x will give us sine x. Since this column is for repeated integration, so again we have to integrate this part. So integration of sine x dx is equal to negative cosine x, and before we have another negative, so negative negative will finally give us positive. So we will get positive cosine x. So this is our last part because we have 0 here. Now complete this sign change, plus, then we will get minus, then plus, then minus. Now make the correspond, that is we have to multiply, the first term will be multiplication of this and this, second term will be multiplication of this and this, and the third term will be multiplication of this two. So this integral can be evaluated, integration of x squared d x squared sine x in terms of x can be evaluated by this tabular technique. But at first what we are writing the product of x squared and cosine x. Don't think about the negative and positive sign, we will discuss later after having all the terms. Here we have negative, but we have skipped here, you can see. And the second term will be the multiplication of 2x and sine x, and the last term will be the multiplication of 2 and cosine x. So we have total 1, 2, 3 terms. Now let's focus on the sign before this term. So you can see that if we come by this way. You can see plus plus, you can see here we have plus, so plus plus. Okay, let me write plus 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 minus, the first term will be minus. Again I am saying plus 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 minus minus. So this is how we have found the sign before the first term. For the second term, 2x sine x, you can see here we have negative, so negative positive, automatically 2x with positive, so negative positive negative, negative negative, it will be positive. That means negative positive negative, negative negative positive. So that is how we can find this one also. And the for the last part, 2 cosine x, you can see here we have positive, so positive positive positive, positive positive, you will get positive. So here we have negative x squared cosine x plus 2x sine x plus 2 cosine x. This is our final answer or antiderivative for this integral. That means tabular method can be applied to evaluate this type of indefinite integrals where we have algebraic term, okay, or polynomial function. Instead of using UV integration by parts technique, we can apply tabular method also. So for the same problem, what is the advantage of using tabular technique? If you try to solve the same problem by using integration by parts, that is integration UV technique, so things will be very lengthy, okay, because you have to integrate several times. So that's why instead of integration by parts, tabular method is somehow helping us to get the answer quickly. Okay, so we have the result. Okay, since we have been given indefinite integral, so you know that with this antiderivative there will be a constant c, so let's plug plus c. Similarly, for this one we have the indefinite integral, we can impose a constant plus c. Similarly here we can impose a constant plus c. So I hope in this part I have tried to cover integration by parts and tabular method. So I hope you have understood all these things, and then we will try to focus on the second part, that is integration, in how to integrate trigonometric functions. Okay, so we have discussed u substitution technique, indefinite integral, definite integral, and in this part we have discussed integration by parts and tabular method. Let's focus on this one, integrating trigonometric functions.